We're going on today to talk about equivalent expressions. An equivalent is a big fancy word for, you guessed it, equals. So 2, 3, 4, 5 algebraic expressions are equivalent. We can have as many equivalent expressions as possible. And actually, that's the beauty of math, making sure everything is equal. If they have the same value for anything we substitute in, whether we put in a 1, a 5, a 0, a negative pi, a negative e, a radical 4,559, it doesn't matter. We'll always get the same answer. It's the ultimate subject in being fair, math. So what we have in front of us here is a table, and we have some expressions that kind of look alike. I got a 5, got a 5, got a 5, got some x's. And this one has 3, this one has 3, this one has 15. So, well, we can do this the long way. And the long way would be to substitute each number in and figure out our answer. All right, so this one comes out to be 20 when I put a 7 in. That's 35 minus 3, so that's 32. And this is 35 minus 15, and that's 20. Hey, so these two are the same. All right, let's put a 0 in there. Normally I like 0, because 0 has some special qualities. 5 times negative 3, so we get negative 15. Here's that special quality. 5 times 0 is 0. So this answer is minus 3. This is 5 times 0 minus 15. Whoops, that's not right. Let me rewrite that again. All right, here we go. This is 5 times 0, then that quantity minus 15. 0 minus 15. Hey, negative 15. It's the same as that column. And I think you can figure out that if we do this last one also, that they're going to be the same. Now, why is that? Well, we're going to prove it on the next page. And just to make sure we got it, so what we're saying is that this, whoops, got to relearn my toolbar here. That's what I wanted. I wanted my shape thing. This expression is equivalent to this expression. We can see that the last one was equivalent because basically if we remembered our distribution, we distributed that 5, we passed it out to that x, we got 5x, and we passed it out to that 3, and we got minus 15. I'm pretty sure most of you saw that as I was going through the table. So that's all we're doing when they say which of the following expressions is equivalent. We're just going to apply all our rules of associative, commutative, and distributive. So we're here, and we're going to find equivalent expressions. An equivalent expression just means to follow those PEMDAS laws. And let's boil this down from this big mess to one of these short little answers. So for example, I see multiplying, I see adding, and I see subtracting, and I see parentheses. So PEMDAS says I have to do parentheses first, but when I look inside my parentheses, it's 2x plus 1. And I say, hey, that's nice. Nothing can happen there. I can't add 2x plus 1. Don't have any exponents. Do I have any multiplication going on here? Yes. I'm distributing a 5 to everybody. So 5 times 2x is 10x, 5 times 1 is 5, and minus 4. No division, And now I have left addition, subtraction. Remember, we move from left to right with addition, subtraction. One is not more powerful than the other. Can I take 10x and add it to 5? No. So I cannot add these two together. Can I take a positive 5 and minus a 4 from it? Absolutely, and I get a plus 1. And then this 10x had nobody to combine with. So I guess my answer is 3. This next one seems a little long, but I'm not daunted by that. Again, I see expression is equivalent to, and that's fancy for doing PEMDAS. I am just going to apply all my rules of PEMDAS and distributive and just go step by step till I get an answer. Parentheses. Once again, it's 3x plus 1, and I know I can't add x's to numbers. I can multiply them, but I can't add. There are no exponents. Do I see any multiplying? Yes, right here. I'm going to distribute that 4 to everybody in parentheses. 12x plus 4 minus 2 that's still all over 2 minus 5. All right, so now I do have some division going on here. And that's what makes this kind of cool. I'm saying divide by 2. And who's getting divided by 2? Everybody above this line. So I really could divide the 12x by 2 and get 6x. I could divide the 4 by 2 and get 2. I can divide the 2 by 2 and get minus 1, and then I have the minus 5 left over. I'm down to my addition and subtraction. Well, I can't add 6x and 2 because one's a variable and one's a number, but I can do 2 minus 1, which gets me a plus 1. And then I still have the minus 5. And I can do 1 minus 5. So my answer is 6x, and 1 minus 5 is negative 4. Now I'm going to go back here and just show you that I love math because I have a lot of options. I could have chosen to do 4 minus 2 and get 12x plus 2 divided by 2. Then I can take half of everything here. Half of 12x is 6x, half of 2 is plus 1, and there's the minus 5. Look, and we're at the equivalent stage. Tomorrow we're going to look at this. Write equivalent expressions for the following. And that's kind of going backwards. Here I'm giving you the short, and you're going to have to go backwards and find me something that could get me to that. But we're going to leave that for tomorrow. Likewise, we're going to try these in class tomorrow. Kind of looks like the one we just did. Don't worry, it's pretty easy. Okay, as usual, see you tomorrow.